Hello everyone. So welcome to our new lecture. In this lecture, we are going to see the application of Pythagoras theorem. Okay. So let us start first with the first application. So here example number 1 is given, that is in triangle ABC. In triangle ABC, angle C is an acute angle. So this angle is an acute angle. Okay. Segment AD is perpendicular to segment BC. So this segment AD is perpendicular to the side BC. Okay, we have to prove that AB square is equal to BC square plus AC square minus 2BC into DC. Okay, we have to prove this. So first of all, in the given figure, let us take AB is equal to C. Okay, I have taken AB is equal to C. AC will be my B. AD will be P. BC will be A. And DC is going to be X. So in that case, BD will be A minus X. Okay. BC क्या है हमारा कंप्लीट A है और DC क्या है हमारा X है. So BD क्या हो जाएगा? A minus X हो जाएगा. Okay. So in triangle ADB, I am considering this triangle ADB. Okay, angle D is 90 degree, so I can use Pythagoras theorem. So by applying the Pythagoras theorem, I will get AB square is equal to BD square plus AD square. Okay, so AB is my C, so I have taken C square is equal to A minus X raised to square plus other side is my AD, so AD is nothing but P, so I will take here P square. Okay, so I have got an equation C square is equal to A minus X bracket raised to square plus P square. Okay, so now we will simplify this equation. So A minus X raised to square is nothing but A square minus 2ax plus x square. We have just used a simple expansion formula, that is a minus b bracket raised to square is equals to a square minus 2ab plus b square. Okay, we all know this formula, so we have applied this over here. Okay, this is the expansion of a minus x raised to square, and p square will be written as it is. Okay, so here you will find p square. Okay, so this is the equation number 1. Now I will consider triangle ADC. Again, this angle, that is angle D, is 90 degree as AD is perpendicular to side BC. Okay, so again we can use Pythagoras theorem. So if we apply the Pythagoras theorem in this triangle, what we will get? AC square is equal to AD square plus DC square. So AC is my B, so B square is equal to P square plus x square. Okay, this is the other side, so I will get here x square. Okay, now I want the value of p square, so this will become b square minus x square. Okay, so my equation number 2 is p square equal to b square minus x square. Now I will substitute the value of p square in equation number 1. Okay, so in place of p square in equation 1, I will write b square minus x square. Okay, so I will get c square is equal to a square minus 2ax plus x square, and in place of p square we will be writing b square minus x square. Okay, so plus x square and minus x square get cancelled. Okay, so we have got a square plus b square minus 2ax equal to c square. So what is c? C is nothing but my ab, so I have taken here ab square is equal to a is my bc, so bc square plus b is my ac, so ac square minus again 2 into a is bc and x is dc. So after substituting the values, okay, we have got an equation that is a square, sorry, AB square is equal to BC square plus AC square minus 2BC into DC. So this was the first application where we have got this particular formula. Okay, now let us see the second application. Now here you can see in triangle ABC, angle ACB is an obtuse angle. So this angle is an obtuse angle. So what is obtuse angle? Angle which is more than 90 degree, which have the measurement more than 90 degrees. That angle is nothing but obtuse angle. So this angle is obtuse angle where segment AD is perpendicular to segment BC. Okay, so this segment AD is perpendicular to segment BC. We have to prove that AB square is equal to BC square plus AC square plus 2 into BC into CD. Okay, again we have taken DC as my X, BC as my A, AB is nothing but C, AC is my B, and I have considered AD as my P. Okay, so now we can apply Pythagoras theorem in triangle ADB. Okay, the complete triangle we have considered here. So by applying the Pythagoras theorem, we will get C square is equal to A plus X raised to square plus P square. So BD is what? BD is nothing but X plus A or A plus X. So BD, in place of BD we have taken A plus X raised to square, and AD is my P, so P square. Okay, now we will expand this A plus X raised to square, so we will get A square plus 2AX plus X square. Okay, and plus P square. This is my equation number 1. Now let us find the P square to substitute it in the equation 1. Okay, so now I will consider triangle ADC. Okay, so in triangle ADC, again we will apply the Pythagoras theorem. We will get B square is equals to X square plus P square. So B square is equal to X square plus P square. So in that case, P square is nothing but B square minus X square. This is my equation number 2. Okay, I will substitute the value of equation 2 in equation 1. So I will get C square is equals to A square plus 2x plus B square, as minus X square and plus X square will be eliminated. So we will get C square equal to A square plus B square plus 2AX. Okay, and after resubstituting the values, we will get the equation AB square is equal to BC square plus AC square plus 2BC into CD. Okay, so this was the second application of the Pythagoras theorem. Now by applying these two applicational formula, we can find a new formula, and the formula which is attained by using these two formula, okay, that complete procedure is called as Apollonius theorem. Okay, so let us see Apollonius theorem now. In triangle ABC, if M is the midpoint, so this point M is the midpoint for side BC. What we have to prove? We have to prove that AB square plus AC square is equal to 2AM square plus 2BM square. Okay, we have to prove this. So what is given to us? That in triangle ABC, M is the midpoint. So I have taken the M, that is my midpoint for segment BC. Okay, now we have to prove AB square plus AC square is equal to 2AM square plus 2BM square. Okay, now I will draw a segment AD perpendicular to side BC. I am going to draw a segment AD, okay, this particular segment AD, which will be perpendicular to side BC. Okay, now if segment AM is not perpendicular to segment BC, then out of angle AMB and angle AMC, one is obtuse angle and the other is acute angle. Now as we know that AM is the midpoint and it is not perpendicular to segment BC, so in that case one angle is obtuse and one angle is acute. So angle AMC, this angle is acute angle and this angle is obtuse angle. So this is the obtuse one and this is the acute angle. Okay. Now by applying the example 1 or the application number 1 and application number 2, what we will get? We will get that AB square is equal to AM square plus MB square plus 2BM into MD. Okay. This will be my equation number 1. Okay. By applying the first example or first application formula, I will get AB square is equal to AM square plus MB square plus 2BM into MD. And by the second application formula, we will get AC square is equals to AM square plus MC square minus 2MC into MD. Okay. So we can write AC square is equals to AM square plus MB square as MC and MB must be equal. Why they are equal? Because M is the midpoint of side BC. So M अगर midpoint है तो BM और MC दोनों भी क्या होने चाहिए? सेम साइज के होने चाहिए. Okay. So in place of MC I have taken MB square minus 2BM into MD. Okay. Now if I will add equation 1 and equation 2, what I will get? I will get AB square plus AC square is equal to 2AM square plus 2BM square. So AB square plus AC square is equal to AM square plus AM square क्या हो जाएगा? AM square plus AM square क्या हो गया? 2AM square हो गया. BM square plus BM square क्या हो गया? 2BM square हो गया. Okay. Now plus 2BM into MD minus 2BM into MD क्या होने वाला है? Cancel हो जाने वाला है. So this is cancelled. So we get an equation AB square plus AC square is equal to 2AM square plus 2BM square. And this equation is nothing but Apollonius equation and it is called as Apollonius Theorem. This is the Apollonius Theorem. So we have to keep in mind, in any triangle where M is the midpoint, okay, from one of the vertex, then we can apply this Apollonius Theorem and we will get an equation that is the side where the midpoint is not there, other two sides. Okay. M midpoint कौन से साइड पे है? BC में है. तो उसके अलावा के जो दो, उसको छोड़ के जो दो साइड्स हैं AB और AC, उनका स्क्वायर, ओके, उसका सम हमें लेना है एंड दैट विल बी इक्वल टू द 2AM स्क्वायर. ओके. सो जो हमारी लाइन होगी जो मिड पॉइंट तक ज्वाइन होने वाली है वर्टेक्स से, वो लाइन प्लस 2BM स्क्वायर. ओके. सो दिस इज द BM स्क्वायर. ओके. मिड पॉइंट से जो हमारे सेगमेंट्स क्रिएट हो रहे हैं उसमें से एक सेगमेंट. So this is the Apollonius Theorem. Okay. Now your homework will be, you have to write down application 1, that is this example number 1, example number 2 and the Apollonius Theorem in your notebook. Okay. Up till here you have to write it down in your notebook. In the next lecture we will use this theorem and applications to solve some questions. Okay. Until then, goodbye.